temperature. So we are always taught in high school or in elementary or even in college that to convert degrees Celsius to Fahrenheit, we just use, or vice versa, we just use these formulas. 9 over 5 degrees Celsius plus 32. Then for degrees Celsius, 5 over 9 degrees Fahrenheit minus 32. Right? And so that, just a quick example, if we convert 0 degrees Celsius to Fahrenheit, degrees Fahrenheit, we just use this formula above, degrees Fahrenheit. So we have 0 degrees Celsius. So 9 over 5 times 0 plus 32. So we'll then have 0 degrees Celsius as equal to 32 degrees Fahrenheit. Have you ever asked yourself or even wondered where do these formulas came from? Like how did these formulas just pop up and then give us exactly why and how to convert? So if you are one just like me, this video is for you. So it all started from the device commonly known as thermometer. This device is used to measure this drawing, to measure the temperature, of course, of a body. So as a matter of fact, it always seems that temperature isn't constant, especially if it is changing pressure or the volume is changing based on the laws of Boyle's law, just like those laws. But just to assume, or for some assumption, let's just say it's fixed like that. So as we know, water has a boiling point of 100 degrees Celsius, 4 degrees Celsius, and its freezing point is 0 degrees Celsius. So by the way, the mercury inside the thermometer will change up or down depending on the temperature. So that's how they read, based on the mercury content of the thermometer. And siya mercury sa sulod, then mo-change siya depending on what you put or where do you put the thermometer, either on hot or cold surfaces. And so going back, the boiling point of water is 100 degrees Celsius and 0 degrees Celsius for its freezing point. So let me write first, this is degrees Celsius and this is degrees Fahrenheit and this is Kelvin. So for degrees Fahrenheit, the freezing point of it is 32 degrees Fahrenheit based on the conversion we had. And its freezing point is 212 degrees Fahrenheit. So, kanarasang duha. And later on, we'll tackle Kelvin. And this idea that if the temperature change from the starting point to some degrees Celsius here, it's like that. We note the change. We put some notation, the change as x or any variable just to denote the change in temperature. And notice that from the freezing point to boiling point of the water, it remains unchanged. So let's assume that as L. So all else, this L of these temperatures here remains unchanged. So therefore their L are equal. So to find the change in temperature, the change in temperature, that would be final temperature to minus initial. So for degrees Celsius, it would be 100 degrees Celsius minus 0 degrees Celsius. So that's final minus initial. So that's the change. And for the Fahrenheit, it would be 212 degrees Fahrenheit minus 32 degrees Fahrenheit. So we have that. And then for the change for any temperature inside or between 100 and 0, the freezing point and boiling point, we denote as degrees Celsius. We denote that as x. So the ratio, therefore, of the fixed temperature 100 and 0 will be L over X. So L over X will simply means 100 degrees Celsius minus 0 degrees Celsius, the change in temperature, over the other change in temperature, which is the X, or degrees Celsius minus 0. So like that. Then for the Fahrenheit, it will be the same. So L over X is equal to the change in temperature in terms of Fahrenheit, 212 degrees Fahrenheit minus 32 degrees Fahrenheit, divided by this still X, we denote as X, degrees Fahrenheit from 0, degrees Fahrenheit minus, so degrees Fahrenheit minus 32 degrees Fahrenheit. This is some temperature degrees F from the initial 32 degrees Fahrenheit. So the change is final minus initial. That's why degrees Fahrenheit minus 32 degrees Fahrenheit. And since this L over X here is equal to L over X here, we can equate their equivalent values. Thus, 100 degrees Celsius minus 0 degrees Celsius all over 0 degrees Celsius minus 0 can be equated to 212 degrees Fahrenheit minus 32 degrees Fahrenheit all over degrees Fahrenheit minus 32 degrees Fahrenheit. And it all came from here. So if we simplify this left hand side expression, 100 degrees Celsius minus 0 degrees Celsius, you subtract nothing from 100 degrees Celsius, it will remain 100 degrees Celsius. And the denominator, you get degrees Celsius minus 0, that will remain degrees Celsius. And for the right side, 212 minus 32, that would be 180 degrees Fahrenheit. And below will remain the same. And so now, if we isolate degrees Celsius, because that's what we want, to one side of the equation, we can then have the formula by cross multiplication. So 100 degrees Celsius times degrees Fahrenheit minus 32 degrees Fahrenheit, and then divided by 180, because this C can go to above and 180 degrees Fahrenheit can go below, so 180 degrees Fahrenheit. So from this equation, let's distribute 100 to the parentheses. So 100 degrees Celsius degrees Fahrenheit. All I'm doing here is just distributing this 100 degrees Celsius inside. So 100 degrees Celsius degrees Fahrenheit minus 100 degrees Celsius minus 32, or 100 degrees Celsius times 32 degrees Fahrenheit. That's all over 180 degrees Fahrenheit. And then again factoring out 100 degrees Fahrenheit, will leave me degrees Celsius minus 32, right? All right, all over 180 degrees Fahrenheit. And if I cancel out this degrees Fahrenheit, I'm gonna left with 100 over 180. Simplifying that will give me 5 over 9. And then finally we got the equation to convert degrees Fahrenheit to degrees Celsius. So this is now the formula that came from here. So all we did was get the boiling point and freezing point of water, and then get some random temperature inside it in degrees Celsius and in degrees Fahrenheit, and get the ratio of the change in temperatures. So 100 degrees Celsius minus 0 degrees Celsius is the change, boiling point and freezing point, and degrees Celsius minus 0 is the change from freezing point to some temperature C. And for degrees Fahrenheit, we'll do the same, but for the values of degrees Fahrenheit. So boiling point minus freezing point, that's 212 minus 32. And then the change also from degrees, or from 32 degrees Fahrenheit to degrees Fahrenheit, some temperature in degrees Fahrenheit. Then we equate the ratio, and finally we've got this. By rearranging that, we can get also this formula here, 9 over 5. So basically, that's the point of making this video, just to show where this formula came from. And just an additional information, to get the Kelvin, you just have to add 273.15 to degrees Celsius to the temperature that is in degrees Celsius. But sometimes they omit this 0.15, and just to make it simpler, you just add 273. And for degrees Rankine, the temperature should be in degrees Fahrenheit, and then before adding 460. So that's it for the derivation of formula of temperature conversions. And thank you so much for watching.